Hey guys! Welcome to AWS DBA. In this session, we are going to see about Amazon RDS, DB instance storage. Amazon RDS, DB instance storage. DB instances for Amazon RDS, for MySQL, MariaDB, Postgresql, Oracle, and Microsoft SQL Server use Amazon Elastic Block Store, Amazon EBS, volumes, for database and log storage. Depending on the amount of storage requested, Amazon RDS automatically stripes across multiple Amazon EBS volumes to enhance performance. Amazon RDS storage types. Amazon RDS provides three storage types: General Purpose SSD, also known as GP2, Provisioned IOPS SSD, also known as IO1, and Magnetic, also known as Standard. They differ in performance characteristics and price, which means that you can tailor your storage performance and cost to the needs of your database workload. You can create MySQL, MariaDB, Oracle, and PostgreSql RDS, DB instances, with up to 64 TB of storage. You can create SQL Server RDS, DB instances, with up to 16 TB of storage. For this amount of storage, use the Provisioned IOPS SSD, and General Purpose SSD storage types. The following list briefly describes the three storage types. General Purpose SSD. General Purpose SSD volumes offer cost-effective storage that is ideal for a broad range of workloads. These volumes deliver single-digit millisecond latencies, and the ability to burst to 3000 IOPS, for extended periods of time. Baseline performance for these volumes is determined by the volume's size. Provisioned IOPS. Provisioned IOPS storage is designed to meet the needs of IO-intensive workloads, particularly database workloads, that require low IO latency and consistent IO throughput. Magnetic. Amazon RDS also supports magnetic storage for backward compatibility. We recommend that you use General Purpose SSD or Provisioned IOPS for any new storage needs. The maximum amount of storage allowed for DB instances on magnetic storage is less than that of the other storage types. Several factors can affect the performance of Amazon EBS volumes, such as instance configuration, IO characteristics, and workload demand. General Purpose SSD storage. General Purpose SSD storage offers cost-effective storage that is acceptable for most database workloads. The following are the storage size ranges for General Purpose SSD DB instances. MariaDB, MySQL, Oracle, and PostgreSql database instances, 20 GB to 64 TB. SQL Server for Enterprise, Standard, Web, and Express editions, 20 GB to 16 TB. Baseline I/O performance for General Purpose SSD storage is 3 IOPS for each gigabyte, with a minimum of 100 IOPS. This relationship means that larger volumes have better performance. For example, baseline performance for a 100 GB volume is 300 IOPS. Baseline performance for a 1 TB volume is 3000 IOPS, and baseline performance for a 5.34 TB volume is 16,000 IOPS. Volumes below 1 TB in size also have ability to burst to 3000 IOPS for extended periods of time. Burst is not relevant for volumes above 1 TB. Instance I/O credit balance determines burst performance. Many workloads never deplete the burst balance, making general-purpose SSD an ideal storage choice for many workloads. However, some workloads can exhaust the 3000 IOPS burst storage credit balance, so you should plan your storage capacity to meet the needs of your workloads. I/O credits and burst performance. General-purpose SSD storage performance is governed by volume size, which dictates the base performance level of the volume, and how quickly it accumulates I/O credits. Larger volumes have higher base performance levels, and accumulate I/O credits faster. I/O credits represent the available bandwidth that your general-purpose SSD storage can use to burst large amounts of I/O, when more than the base level of performance is needed. The more I/O credits your storage has for I/O, the more time it can burst beyond its base performance level, and the better it performs when your workload requires more performance. When using general-purpose SSD storage, your DB instance receives an initial I/O credit balance of 5.4 million I/O credits. This initial credit balance is enough to sustain a burst performance of 3000 IOPS for 30 minutes. This balance is designed to provide a fast initial boot cycle for boot volumes, and to provide a good bootstrapping experience for other applications. Volumes earn I/O credits at the baseline performance rate of 3 IOPS for each gigabyte of volume size. For example, a 100 GB SSD volume has a baseline performance of 300 IOPS. When your storage requires more than the base performance I/O level, it uses I/O credits in the I/O credit balance to burst to the required performance level. Such a burst goes to a maximum of 3000 IOPS. Storage larger than 1000 GB has a base performance that is equal or greater than the maximum burst performance. When your storage uses fewer I/O credits than it earns in a second, unused I/O credits are added to the I/O credit balance. The maximum I/O credit balance for a DB instance using general-purpose SSD storage is equal to the initial I/O credit balance, 5.4 million I/O credits. Suppose that your storage uses all of its I/O credit balance. If so, its maximum performance remains at the base performance level until I/O demand drops below the base level, and unused I/O credits are added to the I/O credit balance.